I'm sure you're all familiar with the Arduino Serial Plotter. It works pretty well. All you have to do is output your values in a comma-separated list, and it will plot them on this nice graph. Now, it's okay, but it is pretty limited. You can't zoom in, there's no controls, you can't take a screenshot. It's great for simple things, but it's not great for anything more complex. So I thought to myself, why not try and build something better? Build something cross-platform that runs in the browser. So I was inspired to do this because I'm using this Web Serial API quite a lot now. So I'm testing out one of my new boards from PCBWay. This is a really nice audio monitor. So you can see my audio trace here. Got a nice spectrogram, and we've got a pitch or tuner. So if I try and whistle, then it kind of works. But anyway, Web Serial is now pretty well supported. So if you look at Can I Use, then you can see it's available on Chrome, Edge, and Opera. So building a Web Serial plotter is actually fairly straightforward. So you can see here we've got our nice trace coming through. We've got a legend. We can change this. So we can kind of change, let's change temperature to be, let's choose a nice pink color. So let's change that color. Let's put it back. That's not the best choice of colors. Let's do dark blue. So we can update all of our trace. We've got settings, so you can change the auto scale. So if we turn off auto scale, then we can change this to go from 0 to say 50 or 10. Let's do 10 to 20. Or we can put back to auto scale. Can change the time, so currently it's showing relative time, so that's time since we started recording. Can put that to absolute times, now that's the absolute time. We have a history, so it's quite efficient. It uses a ring buffer, so when it goes over 100,000 points, it will start wrapping around, but you can bump that up. It's not that memory hungry. What you can do is you can also pan, so we can pan back through history, see all the graphs. It's got nice momentum scrolling, so it feels quite nice. And we can go back to the live trace, and obviously you've got zoom in and zoom out here. You can download all the data, so you can export the data, just a visible window, or all of the data, and you can choose relative or absolute time for your exports. You can easily save a screenshot, so you've got a save PNG function, it's really good. And we have these nice stats panels. So it's very much a work in progress. I'd like anyone who uses it to try and raise bugs. So we do have some issues you can open, so it's all on GitHub, it's all open source. I'd really like people to contribute if they can, but if you find a problem, then just go over to the Web Serial Plotter repository, and you can do new issue, and then you can choose bug or feature request. And then there's a form to fill out, just saying what you were doing, what you were trying to do. If you can, give us some sample data so we know what didn't work, but raise issues if you find any bugs. There's also a serial console, so you can see all the data being streamed, and you can also send data to the device. My current firmware doesn't actually do anything, so I can send, but it doesn't do much. But you can see the message here, and you can download these console logs as well, so that's quite handy. But obviously the main thing is the chart. For all you light and dark mode aficionados, then we do have light and dark mode. So I'm currently in dark mode, looks pretty nice. You can easily switch to light mode, and then it's all nice and white. But you can go back to dark mode if you want to. So that's pretty much it, to be honest. Head over to GitHub, raise some issues. It's all online, so you can use it online, webserialplotter.atomic14.com, or you can run it locally if you want to. All the data is stored locally. There's no data sent off to a server. It's all run locally in the browser, so you don't need to worry about any privacy concerns. None of the data is being recorded. So yeah, and if you do have a problem, open an issue on GitHub. So just thought I'd do another quick test. So this is actually audio data. So I've got my board hooked up with its microphone, outputting the samples. I'm doing this, I think, at 16 kilohertz, which still seems to work. I need to do some testing to see if it's dropping any samples, but at the moment, looks quite good. I'll see what I can actually push this to. Maybe I can go up to 48 kilohertz or something and still get good results. The USB serial connection does tend to be very fast, so it's really down to how performant is my code for actually doing the parsing and the drawing. So I'll do a bit more experiments on that and push the limits of this. I mean, I think for most use cases, this will work really nicely without doing anything crazy. But let me know how you get on with it. I think there will be bugs. It is kind of just been written. So let me know on GitHub when you find the bugs, and we'll try and fix them.